Hello and welcome everybody. In this video, we will cover the high yield genetic diseases and their inheritance patterns. So we will memorize which diseases are autosomal dominant, autosomal recessive, X-linked recessive and X-linked dominant. And then we will look at the various pedigrees and go through them to identify which pedigree represents what. So which is the pedigree for autosomal dominant, autosomal recessive, X-linked dominant or X-linked recessive. So by the end of this video, once you master these genetics concepts, you will be able to answer questions from these genetic concepts confidently more than 90% of the times correctly. So if you like this content, please like, share and subscribe and follow for more. And let's begin. So okay, first of all, beginning with the autosomal dominant diseases, right? Since these are the dominant diseases, therefore the mnemonic for this will also be V for very, P for powerful, and then the entire word dominant, since these are the autosomal dominant diseases. So very powerful, and V would be 2 times, right? So very powerful, and then dominant, and we will see that we will have more than one O or more than one D, right? Dominant. And then we have humans, right? For the humans, we will just use the H, and we will see that H will be raised to the power of 4. We will have different diseases with H. So okay, let's go through this. Very powerful dominant human. So V for von Willebrand's for very, V for von Hippel-Lindau for very. Then powerful, dominant. P for powerful with pseudo hypoparathyroidism with P, and then dominant. DOOMINAANT. So let's begin the word dominant. D for dystrophia myotonica, O for osteogenesis imperfecta, and O for Osler-Weber-Rendu syndrome, also known as hereditary hemorrhagic telangiectasias. Then M is for Marfan's, I is for intermittent porphyrias, N is for neurofibromatosis. Then the A for A, we have a Q, which includes achondroplasia, A for androgenic alopecia, and A for autosomal dominant polycystic kidney disease. Then we have N for Noonan syndrome and T for tubular sclerosis. And then we have H raised to the power of 4. So we've already covered hereditary hemorrhagic telangiectasia, so we'll not include here. So H to the power 4, remember that we will begin with some diseases which will affect the CVS, then the blood, and then the CNS. Okay, so the blood diseases that affect the CVS are hypercholesterolemia, as well as hypertrophic obstructive cardiomyopathy. And then the diseases that affect the CNS would be hereditary spherocytosis, where the disease that affects the blood is hereditary spherocytosis, and the disease that affects the CNS would be Huntington's disease. So just a quick review, very powerful dominant humans, right? V for von Hippel-Lindau, V for von Willebrand, P for pseudo hypoparathyroidism, D for dystrophia myotonica, O for osteogenesis imperfecta, O for Osler-Weber-Rendu, M for Marfan's, I for intermittent porphyrias, N for neurofibromatosis, A for achondroplasia, A for androgenic alopecia, and A for autosomal dominant polycystic kidney disease. And then N for Noonan syndrome, and T for tuberous sclerosis, and then H. The first two H with the CVS, which is hypercholesterolemia and hypertrophic obstructive cardiomyopathy. And then for blood, hereditary spherocytosis, and then for CNS is Huntington's disease. So that concludes our autosomal dominant diseases, and after this let's move on to the autosomal recessive diseases. Now for autosomal recessive, remember it's like simple reading your ABCs, right? So the mnemonic is A, then B, then C, then D, then E, then F, then G, and then H. So up till H, we are going to read the ABC, and after H, I have made the mnemonic VIX PS PlayStation, right? So VIX PlayStation. VIX is basically a website, but okay, for a mnemonic VIX PS VIX PlayStation. So let's begin with the autosomal recessive. So first of all would be albinism, A autosomal recessive polycystic kidney disease, B beta thalassemia major, C cystic fibrosis, D deafness, E emphysema, F. Friedreich's ataxia, G. Gaucher's disease, G. galactosemia, G. glycogen storage diseases, H. hemochromatosis, H. Hurler's syndrome, W for I for Wilson's disease, X for xeroderma pigmentosum, and P for phenylketonuria, and S for sickle cell disease, right? So just a quick review of the diseases for autosomal recessive would be A, B, C, D, E, F, G, H, and then Vicks PlayStation. A for albinism, A for autosomal recessive polycystic kidney disease, B for beta thalassemia major, C for cystic fibrosis, D for deafness, E for emphysema, F for Friedreich's ataxia, G for Gaucher, G for galactosemia and glycogen storage diseases, H for hereditary hemochromatosis, H for Hurler's syndrome, and then WI for Wilson's, X for xeroderma pigmentosum, P for phenylketonuria, and S for sickle cell disease. So these were the autosomal recessive diseases. Now let's move on to the X-linked recessive disease. For the X-linked recessive diseases, the mnemonic is B-wise fools. Fools, in the B-wise we just have B, and then in the wise we just have W, and then in the fools we just have F. Whereas for gold we have GOLD, all of them, and has hope, in has hope we have H and H. So let's begin. B for Bruton's A gamma globinemia, wise W for Wiskott-Aldrich syndrome, fools F for Fabry's disease, G for G6PD deficiency, B wise fools go old, so O for ocular albinism, L for Leishman syndrome, D for dystrophies such as Duchenne's and Becker, H for Hunter syndrome, and H for hemophilia A and B. And if you want chronic granulomatous disease, although like it has two inheritance pattern, it can both be autosomal recessive and as well as X-linked recessive. So but if you want, you can add it to the G over here, the gold mnemonic, right? So let's quickly revise our X-linked recessive diseases. B wise fools, gold has hope. B for Bruton's A gamma globinemia, W for Wiskott-Aldrich syndrome, and then G for fools, F for Fabry's disease, G for G6PD deficiency, O for ocular albinism, L for Leishman syndrome, and D for dystrophies such as Duchenne and Becker, H for Hunter syndrome, and H for hemophilia A and B, and of course chronic granulomatous disease has two inheritance patterns. Next off we have X-linked dominant diseases, right? And these are sort of very rare diseases, right? And you can remember them by Dr. X, right? So X-linked dominant diseases are by Dr. X. So Dr. has the D and X has the X, right? So X is for Fragile X syndrome and Dr. is for vitamin D resistant rickets, right? Next off we have the mitochondrial inheritance diseases, and I have not made any mnemonic for them because these are the most complex diseases with the most complex names, and they are just pronounced with these two alphabets that are at the start of mitochondrial and at the end. So they begin with M and L. So the one that begins with L, M is myoclonic epilepsy with rugged red fibers, Murph syndrome, right? That's with the M. And then with the L, we have two of these with the L, so it's L square, Leber's hereditary optic neuropathy as well as Ney syndrome. So that was pretty straightforward. MLL. So M for myoclonic epilepsy with rugged red fibers, and L for Leber's hereditary optic neuropathy, and L for Leigh syndrome. Whereas X-linked dominant were Dr. X with vitamin D resistant rickets and Fragile X syndrome. Next off we have Down syndrome. Just a quick review about Down syndrome, that which are the values that are going to go up in Down syndrome and which will go down. So in order to memorize this, I have just memorized it like this, that whichever name has an H in it, those values will go up, and the names that do not have any H will go down. So beta HCG along with inhibin both have an H in them, so they go up, whereas alpha fetoprotein and estriol don't have an H in them, so they go down, right? And the mechanism for Down syndrome, of course, the majority of cases is due to meiotic neuron disjunction, and the rare cases in which you have a younger mom, then it is due to Robertsonian translocation. And the common complications associated with Down syndrome are Hirschsprung's disease, Alzheimer's, ALL, and duodenal atresia. Okay, now let's look at the pedigrees in order to identify whether this is an autosomal dominant pattern or X-linked dominant pattern or autosomal recessive or X-linked recessive. So let's begin by looking at this pedigree first of all, right? So the principle number one for looking at pedigrees would be to first of all to look for mitochondrial disease. And how do you look for mitochondrial disease? You always look at the mom and see whether the disease is going from mom to all. From mom, the boys and the girls are all inheriting the disease. That means it's mitochondrial, because mom's mitochondrial DNA goes to both the boys and girls, right? So if it's mom to all, excluded. That's a mitochondrial disease from our MERV and Leigh syndrome and Leber's hereditary optic neuropathy, right? Once you don't find this pattern, this is not present, then you go and see whether the disease is skipping generations or not, right? So it's first of all you'll see, okay, the disease is not skipping a generation, right? It's going from generation 1 to generation 2. But once you find that it's not skipping a generation, then you have to analyze, okay, what's the gender? Who is this going from and to? So if it's going from D to D, D to D means dad to daughter, right? And no of these going from M to M. M to M means no male to male transmission, or you can say no dad to son transmission, right? But it's only dad to daughter. That means it's an X-linked dominant disease. So dominant means it's not skipping any generations, it's present in all the generations. And dad to daughter means it's going by the X chromosome of dad directly to the daughter. That's why, since the son don't get the dad's X chromosome, they are not getting the disease, right? So dad to daughter disease is the X-linked dominant, right? And then if you find out that no dad to daughter pattern is present, but the disease is not skipping generations, right? The disease is present in every generation, then you will come to the conclusion that it is autosomal dominant. So in order to find whether a disease is dominant, right, there are 3 steps. First of all, always look for mom to all mitochondrial pattern. If it's not present, then number 2, look for whether the disease is skipping generations or not. If it's not skipping generations, then you look for, okay, is it dad to daughter? Because of course it can't be from dad to son, right? If it's dad to daughter, that means it's X-linked dominant. If it's just not limited from dad to daughter, rather it's going from dads to daughters and sons both, then it is an autosomal dominant disease. Okay, so this was our algorithm number 1 for determining the disease inheritance pattern in pedigrees. Next off, again, we are going to look for the recessive diseases, right? So again, for any disease, first of all, look for mom to all, whether the mom is passing the disease to both the sons and the daughters. So if the mom over here is passing the disease both to the sons and daughters, of course it's mitochondrial, which we discussed right now, MERV syndrome, Leber's hereditary optic neuropathy, along with the Leigh syndrome, right? But whereas if we find out that it's not mitochondrial, then we are going to start looking for the skipping of generations. So is it skipping generations or not? If it was not skipping generations, we went through the dominant route. But now in this situation, we find out that it is skipping generation, right? And once it is skipping generation, the pattern is that there are unaffected parents, and the unaffected parents are leading to a son, right? There is no male to male transmission, right? But both the parents are unaffected and the son is getting it, which means indirectly that the mom was actually a carrier and was not showing the disease, and the mom has actually passed it to the son, which means that this type of disease is X-linked recessive. So remember, number 1, it has to be skipping generations, of course, and it doesn't have to be mom to all. And number 2, 2 unaffected parents need to give birth to a son who is affected. So this is an X-linked recessive. Whereas on the other hand, if you don't find this pattern of 2 unaffected parents giving rise to an affected son, that means that this disease is autosomal recessive, in which both the sons and the daughters are both getting the disease, regardless of it getting from 2 unaffected parents to an affected son. Okay, so let's quickly review our diseases once more, do a rapid review, and then we'll conclude the video. So our autosomal dominant diseases are very, very powerful dominant humans. So V is first of all for von Willebrand's disease, V is for von Hippel-Lindau, powerful P is for pseudo hypoparathyroidism parathyroidism. D is for dystrophia myotonica. O is for osteogenesis imperfecta. O is for Osler-Weber-Rendu syndrome. M is for Marfan's. I is for intermittent porphyria. N is for Noonan syndrome. A is for achondroplasia. A is for androgenic alopecia. And A is for autosomal dominant polycystic kidney disease. N is for Noonan's. T is for tuberous sclerosis. H is for hypercholesterolemia. H for hypertrophic obstructive cardiomyopathy. H is for Huntington's disease, and H is for hereditary spherocytosis. This was an autosomal dominant. Now for the autosomal recessive, A, B, C, D, E, F, G, H, Wicks, PlayStation. A is for albinism. A is for autosomal recessive polycystic kidney disease. B, beta thalassemia major. C, cystic fibrosis. D, deafness. E, emphysema. F, Friedreich's ataxia. G, Gaucher's disease. G, galactosemia. G, glycogen storage diseases. H, hemochromatosis. H, Hurler syndrome. Wicks, Wilson's disease. Xeroderma pigmentosum. PS, phenylketonuria, as well as sickle cell disease. X-linked recessive diseases. B, Weiss Fools, gold has hope. B, Bruton's A gamma globinemia. W for Wiskott-Aldrich syndrome. F is for Fabry's disease. G is for G6PD deficiency. O, ocular albinism. L, Leishman syndrome. D, dystrophy, so for example, Duchenne or Becker's muscular dystrophy. H, Hunter syndrome. H, hemophilia A and B. And also you can remember this Hunter syndrome by the hunter having to have a specific X target, and he has to like fix on that particular target and hit that target. So Hunter is X-linked recessive, whereas the Hurler is autosomal recessive, right? And then of course hemophilia A and B, since we also know about these diseases that they mainly affect the sons or the boys. So remember always for the X-linked recessive diseases that they are generally more common in the boys as compared to girls because they are recessive. So the recessive gene can more easily be expressed when there is only one X chromosome, and that occurs in males. So in the females, the majority of times they would just be a carrier for these X-linked recessive diseases. But as soon as they go in a male, the boys will get the disease. So whenever you have a boy having a hereditary disease on your exam, always remember B, Weiss Fools, gold has hope, right? So it can be Burton's or it can be Wiskott-Aldrich, Fabry's, G6PD, most likely, right? It can be a girl, really, but most likely ocular albinism, Leishman dystrophy such as Duchenne and Becker, and you already know that mostly boys are affected by the Leishman as well as the dystrophy, Duchenne and Becker, as well as hemophilia, right? And Hunter syndrome along with chronic granulomatous disease. Next up, we have the mitochondrial, which we memorized with MLL. M was for myoclonic epilepsy with rugged red fibers. L was for Leber's hereditary optic neuropathy and Leigh syndrome. Then for Down syndrome, we memorized that two things that go up are beta HCG and inhibin because they both have the alphabet H in them, whereas those that don't have the alphabet H go down, which is alpha fetoprotein and estriol. And then the majority of cases are in the elderly women who are like 40 plus with meiotic non-disjunction, whereas only 1% of the cases it is due to Robertsonian translocation. And Down syndrome is associated with Hirschsprung disease, Alzheimer's, ALL, along with duodenal atresia. And next on, just a quick review of how to analyze the pedigrees for establishing what type of inheritance pattern it is. First of all, always look for mom to all, mitochondrial disease. If it's not present, then look for the skipping of generations. If generations are not skipped and it's dad to daughter, that means it's X-linked dominant because it's not skipping generations and dad is giving to the daughter. So X-linked means dad gave the X-linked chromosome to the daughter, and since it's dominant, so it expressed in the daughter. And if it's not skipping generations but the dad to daughter pattern isn't there, therefore it's autosomal dominant. Whereas for the recessive, again, always look for the mom to all, the mitochondrial disease. Once it's not present, then look for the skipping of generations. If it's skipping generations and the pattern is that and unaffected parents are passing the disease to the son, it means that the mom was actually a carrier on the X chromosome and it was X-linked recessive. That's why it didn't show in the mom, but once it came in the son, it was easily expressed with our mnemonic B, Weiss Fools, gold has hope, right? But if we don't see the pattern of an affected parents to the son, it means it's X-linked recessive. It's not X-linked recessive, it means it's autosomal recessive. And this concludes our discussion on genetic diseases. I hope that you found this video beneficial. If you like this content, please like, share and subscribe and follow for more. And I'll see you in the next video. Till then, happy studying.